Okay, been getting some questions about sequences and exponential growth. So a quick video, let's look at an example. I have a sequence, and if you remember, a sequence has a series of discrete numbers. There's nothing in between them. So this sequence, 5, 25, 125, and dot, 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 of course, goes on forever. So when I look at this, the first thing I need to ask myself is, well, what is happening here? Well, what I'm doing is I'm multiplying by 5, and I'm multiplying by 5 again. So clearly, this is an exponential constant multiplication with a multiplier equal to 5. So I'm going to make a little table, and what I'm going to do with my little table is we're going to go n and t of n. Typically, our n is our input for a sequence, and then some function of n is our output for a sequence. And I'm going to use t of n because it's what our book uses. And so the first term is 5, the second term is 25, the third term is 125. And so then the question becomes, what is the nth term? Well, I already know I'm multiplying by 5 over and over and over again. So one way to think of this is that I am multiplying by 5 n times. So just remember, power of means multiply by that many times. So let's see if this works. If I make a sequence t of n equals 5 times 5 to the n, 5 is my starting point. Well, what I get is that when n is equal to 1, I get 25. So that's off by 1. So there's two ways that we can do this here. Option number 1 is make my sequence t of n equals 5 times 5 to the n minus 1. I'm going to subtract 1 from the power. And so when n is equal to 1, I get 5 times 5 to the 0. Anything to the 0 is 1, so this is 5. So this equation works. So we'll just circle it with a green highlighter. This equation works. The other possibility, the second possibility, is to say that, well, my starting point is going to be n equals 0, so I have to go back a step in order to get my starting point. Now, keep in mind that that starting point is not part of the sequence. The sequence starts at 5. The sequence starts at n equals 1. And so this is just almost like an accounting trick, a number trick, so that my equation will work properly. And so if I go back 1, what I get is I divide by 5 to go back 1, and I get that t of 0 would be equal to 1. And so then my function would be 1 times 5 to the n. And again, if I plug in n equals 1, t of 1 equals 1 times 5 to the 1, but anything to the 1 is, yep, that's 5. Check, that one works as well. Either of these is an acceptable way to do it. The differences are that this one has n minus 1 because I'm starting when n equals 1, and this one has n because I'm starting at n of 0. Excuse me, not n of 0, at n equals 0. Either way is acceptable. How do you know if yours is right? Type it into your calculator. See if it starts at 1 and gives you the correct numbers working your way down. All right. Hope that helps. Hope you learned something. Have a great day.